Okay, so today in lesson 4.8, we're going going back to scatter plots, which we did earlier. I believe we did those. I feel like that we're back in chapter 3. And what we're going to be working with today is before when we worked with them, we just drew what we called a trend line in them, and then we made predictions from it. Today we're going to talk about how can we draw a trend line that is really actually a good fit for the data set. Okay? So I'm not going to make you go through the process of having to find what they call the residuals, the things that will help you determine which is the line of best fit. But that line of best fit comes from an algorithm, a process that you actually go through to get it. So we're going to let the graphing calculator get it for us, or it's already going to be given to us, but we have to be able to interpret from that, okay? So we're going to do what's called linear regression. It's a process of finding that least squares line. The thing that's going to be important that you understand, let's jump over to page 287. There's going to be, when we are working with our graphing calculators, it's going to give us what is called an R value. That's called the correlation coefficient. Everybody find that about, there's a tan box there in the middle of the page, kind of, on page 287. So what's the correlation coefficient? What's variable are they going to use? They're going to use R. So what does it tell us about R? Where will R fall? What values will R fall between?
-1 and -1.
-1 and +1. -1 representing what type of correlation? We've already learned about the types of correlation. Negative representing negative correlation. A positive R value would represent positive correlation. Well, when we have R equal to exactly a +1, we have a line that actually goes through every single point on the scatter plot. We have an exact linear relationship. When we have an R value that is -1, we again have a line that would go through every single point on the data set, and it would have a -1 slope. Anything in between, that line is not necessarily going through exactly every point. It may be touching some of them, but not others. And the closer that the R value is to 0, that's showing us, and so the closer it gets to 0, that's showing us that there's really not much relationship between the two things being compared in the data set. The closer it is to -1, because remember that's the one that's going through all the points, and the closer it is to +1, depending on which one it is, the closer it is, that shows a stronger relationship between the things that are actually being compared. So if we had an R value of -0.94, we would say that that data set, whatever was being compared in that data set, they had a strong relationship to each other. It would be a negative correlation relationship. As one of them was increasing, that would mean the other is decreasing. But if that R value was a -0.45, now we would say that's just a moderate correlation. It's not very strong. It's kind of halfway between -1 there and 0. And again, the closer it gets to 0, so let's say it's a -0.1, -0.1. Now it's pretty close to 0, we would say, you know what, there's probably not much of a relationship at all. Okay? And same thing on the other side, on the positive side. So today we're going to be working with R values, which shows us the relationship between. We've talked about positive correlation, we've talked about negative correlation, we've talked about no correlation. So where would the no correlation be? What kind of an R value would we have? What do you think? 0. We'd have an R value of 0. Or anything really close to it would show us, you know what, there's probably really not much correlation between those things on the data set. Okay, and then we're also going to talk about something called causation today. So we'll talk about that in a little bit here, okay? So we're going to use the graphic calculator ahead again. Get it uncovered and turned on. They've already done an example for us here, but we're going to do it again so that we can get the practice. So here's our data set right here, okay? Whoopsie, I guess I need to touch my pen there. Okay, there's our our data set right there. So we circle that too, so that you know what it is that we're working with here. It's a pretty small data set, but we're going to put it into the graphing calculator. Let the graphing calculator make the scatter plot. We're going to let the graphing calculator show for us the line of best fit, and then we're going to talk about it, okay? So it says step 1, press stat. So find your stat key. Find your stat key. And it should take you to a screen, not the one that is showing on here, but it should take you to a screen where you have the opportunity to edit, sort, and all kinds of things. We want to edit, so press enter. Press enter. We want to make some lists. We're going to put our X values into list 1. We're going to put our Y values in list 2. So here's the deal. If you have anything in your list, we need to get it out of there. So go up to L1, get cursor up onto the list name if there's something in the list, cursor up onto the name, press clear, and then you arrow down and it will dump everything out of there. Getting it to work because I want everybody to really make this happen. So if you have anything in the list, you need to clear it out of there. You would do the same thing with list 2. Get on the list name, press clear, arrow down, it'll dump the data out of there for you. Okay, in list 1, we're going to put our X values. We're going to put 1, 3, 3.5, and 5. So put those 4 X values in your list 1. So they're on your handout there. You can look right there. You don't even have to look up at the board. And in L2, what do you suppose you're going to put? The Y values. And make sure you put them in the same order so that the corresponding Y values go with the X values. Okay? I need to go to the here so you can see that. Okay, when you have both of your lists made, make sure that they both have what? How many items are in each of them? 4. Don't have an extra, don't be short one. Make sure that we have 4 ordered pairs. We're going to line up like ordered pairs in a table. Okay, next thing it says we're going to do is it says we're going to press stat. Okay, so we're to right here. We're going to press stat, step 5. So press stat again. This time, along the top, we want to arrow over so we're on calc. So arrow over to be on the word calc. Step 7 says we're going to press 4. And you can just press the 4 key.
I did the wrong values. I did all these.
Oh, you did the, yeah, go back up to the top. We're practicing with those. Okay, so press 4 and then enter, and you might have to press enter twice. But basically what should happen is you should end up with some sort of a screen like this, okay? So if you can't get it to happen, get your hand up. That's clear. Let's go back and try again, because we're back to step 5. Step. Calc. 4. Enter. There it is. Maybe we press it. You don't have the R's? Okay, we'll get the R's set up for you then, okay? Okay. It's alphabetically, you're going to arrow down. There's a lot of stuff. Diagnostic. Anybody else not have an R value? Okay, let's enter to turn it on. Okay, now it's showing that that's on the screen, so now you'll just go through the steps again, go back to step 5. Okay, anybody else not have R values? Okay. Okay, so now basically what we've done is we have, it is given us, it says Y equals AX plus B. What does that sound like? Mx plus b. That's our slope-intercept form. So instead of using m, they use a. Okay? So a is really our m value. It's the slope. And b is still our y-intercept. So this is telling us where the line is going to cross the y-axis. It's telling us what its slope will be. Do we have a positive or a negative correlation going on here? A Positive. Why? How do we know it's positive?
Because both the R's are closer to 1.
Okay, because both of the R's are positive. The R and the R squared are both positive. Okay, what else? What other clue do we have that we have a positive slope?
Well, the slope A equals
Or positive
1.
correlation. Yeah, the slope is positive, isn't it? I kind of gave it away. How else do we know we have positive correlation? Well, we have a positive slope. Okay, you're not doing that right there, apparently. Calc, enter. 4, enter. Okay, so let's, you see if you can get his thing to show the R value, please. You can, just in case you don't know how there's. Okay, so we know that we have a positive correlation going on here. What do you think, when we look at they say here what the line of best fit is, they tell us, I should have calibrated here, it says right here that our line of best fit is right here. So will you circle this? There's the equation of the line of best fit. They took the A value and they just rounded it to the nearest 100 and put that in for our M value. They took the B value and they rounded it to the nearest 100th and they put it in for the B value in the equation. And so the line of best fit would be Y equals 1 and 25/100ths X minus 1 and 41/100ths. And they say the correlation coefficient is R. When R is close to 1 or -1, we already talked about that. That's very strong correlation. The closer the R is to 0, the weaker the correlation. So does this one have strong correlation or not?
Yeah.
What's the R value?
0.99.
0.99. If we round it, we're going to round that to the nearest 100th also. By the way, we don't care about R squared. You can just cross that out. We care about R right now. So the R value rounded to the nearest 100th is about 99/100ths. That's a pretty strong correlation, isn't it? So what is that really telling us? Let's look back at the table and see what's going on here. What's being compared in this table? Oh, we don't know. So whatever the X values are representing, and whatever the Y values are representing, is showing that one is very strongly related to the other. So give me an example of something that might show a strong positive correlation. Give me an example of something that might show a strong positive correlation. Okay, you can give it back to him then. A strong positive correlation. Gotta think back. We did this already. Anybody think that the more the sun shines on any given day, the higher your test scores? Okay. Well, come up with something for me. You have something, Kate?
The more power a fan uses, the more, the colder the air will get.
Okay, so almost kind of like an air conditioning unit. The more power you have, the more wattage or whatever it's being measured in, the higher that gets, the colder the air also gets. There would be a strong correlation between those two. Okay, good. Give me another one.
The more you drive, the more gas will waste.
Okay, the more you drive, the more times you have to fill up your gas tank. Yeah. The more you drive around, the more you have to fill up your gas tank. So as one increases, so does the other increase. Okay, so we're not gonna actually show the graph for this one. We're just gonna go down now that we kind of know how to use it. Let's go down and do this one. So the table below shows the number of times 4 students run during the week. Take over for me, Josh. Okay, Josh, let me help you out here. Here's where I'm at.
This is how long it takes in minutes for each student to run 1 mile. Use your calculator to find the equation for the line of best fit. What is the correlation coefficient? Describe the correlation.
Okay, thank you. So this time we do know what our x values and our y values are representing. So which one do you think is in control here in that table? Which one do you think should be the x value, the independent variable, and what should be the y? Would it be more, what's in control, the time to run the mile or the number of times the student runs per week? Yeah, so we're gonna make this our x value, so let's go ahead and write that over here, that this will be our x value and this will be our y. So the number of times the student runs, it makes more sense that the time that it takes them to run the mile would be dependent upon that, okay? So we're gonna go to stat again. We're gonna go back and redo our lists. So go into stat, remember how to clear them? Anybody need to ask? And you're gonna put the number of times the student runs in your list 1. You're gonna put the time it takes them to run in list 2. And then after you've done that, let's just stop for a bit and let's stop and think about if there was a relationship between these two things, what type of relationship do you think there would be? Remember you have to think about it. As 1 increases, usually you just always have the x increasing. As 1 increases, what's happening to the other? So as x increases, what's happening to y?
Decreases.
It should be decreasing, right? The time it takes to run the mile hopefully is going down, so we should expect a negative what? Correlation. We should expect a negative slope for our line of best fit, right? Okay, so now let's go and let's do what we have to do to get that line of best fit. What do we have to do? Did anybody remember? Stab again. And we have to calculate 4, enter, and write down your A value or on your worksheet or on your notes sheet, write down the A value rounded to the nearest hundredth. Hopefully it's negative since we think that's what it should be, and our B value should be rounded to the nearest hundredth also. And I'm going to put that, if you would put it in there right, what you probably should get, except I rounded to the nearest tenth. Why did I do that? What do you get, AJ? Negative 1.51. Okay, thanks. I'm going to steal yours. What do you get for your B, AJ? 90. Okay. So in other words, the thousands wasn't high enough to round the hundreds up.
No, it was.
It was.
Except for that rounded up to the 9.
Oh, so you had to round it up to the 90. Okay, gotcha. Okay, so we did get a negative slope. We have a y-intercept of just under 13. So what would the equation of the line of best fit be? Y equals?
Negative 1.51x.
Yeah, negative 1.51x plus 12.90, right? Okay. So do you have an R value? It's rounded to the nearest hundredth. What's the R value rounded to the nearest hundredth?
0.92.
Positive or negative?
Negative.
It better be negative, right? Okay. So R rounded to the nearest hundredth is a negative 93 hundredths. Okay, what are we going to say? What type of correlation do we have here in strength? You think it's strong?
Yeah, it's close to
And but if it's 0.9 or higher, so between that, it's in that region, we can probably say it's a pretty strong correlation. So we're going to say it is a strong what? Negative correlation. So it appears that there is a strong negative relationship between these two. Okay, I want us to see this on the graphic calculator though, so I want us to finish up. We're going to get that line of best fit and we're going to make the scatter plot. So first of all, let's go and create the scatter plot. Anybody remember how to do that?
Second,
Yeah, second y equals, let's do it, everybody, second y equals, and what are we gonna make? What do we have to do? Let's go into the plot one, so press enter, just press enter, and just take it into plot one. Okay, you need to choose the type of graph you wanna make. What do we wanna make?
Scattered.
We want to make a scatter plot. Okay, so if it's not turned on, will you turn it on? So get onto on and press enter and it'll turn it on for you. And then go down into the type and we're going to just choose the first one. Just go ahead and choose the very first one. And then in your X list, you got to have an L sub 1, and in your Y list, you better have an L sub 2. If you don't, you need to get your hand up. In your X list, you should have an L sub 1. In your Y list, you should have an L sub 2. Well, you need to get there first of all. Second Y equals, no. Second Y equals. Second. You and you're holding your calculator down so I can't work with it. Second Y equals. Okay, enter. Okay, and then marks, you need to pick a mark for your 4. You're only going to have 4 points on this scatter plot, right? So get a mark picked. Which marker do you want? You want the plus sign, the dot, the little square, whatever it is you want. Okay. And then we're going to have to go to window though. We're going to have to set a window for this. So go to your window key. And according to the data set that we put in there, we're going to pick a good window. Okay. So do we need any negative x values? No. Okay. Do we need like 100? No, what's the highest x value we have? 5. Okay, let's just to spread this out a little bit, let's go to 10. So we're going to go x min 0. Actually, we better, so we can kind of show a little bit to the left. Let's go x min negative 5. X min negative 5, even though we don't have any negatives. And x max 10. We're in window key. And x scale, let's just go by 1. I think we can do that. We're only going to have a range of 15, so we should be all right. Okay, now we should be to the y min and the y max, right? Okay, what's the smallest y value? 6. Okay, let's do 0. Y min 0. What's our highest y value?
14.
14. Let's go to 20 then. Y max 20. Scale, I think we gotta, this time I think we might go by 2s. Let's use a y scale of 2. Okay, now you should be able to press graph and you should make your scatter plot first of all. If you have any other plots turned on, it might cause havoc. Like you might have to turn them off. Don't change that, leave that at 1. Don't ever change x-res, just leave it at 1.
There's 2.
There was a spot there.
Go to what is the
Go to your y equals, okay, go to your y equals and clear out anything that's in there. There must be something in your guys' y equals screen. Go to y equals and clear out any equations that are in there. If you have any other plots turned on while you're in y equals, if you see any other plots darkened besides plot 1, we want plot 1 darkened, but if any others are, get on them and press enter, it'll turn them off for you.
Can I get back to the screen?
Okay, we're just gonna, the window key?
Yeah.
Okay. Okay, and now you should be able to press graph and it should make a scatter plot for you. Right?
Yeah.
Okay. Well, I think it will, I think we can do this. Let's just go, let's go to the bars key, bars. Did everybody find the bars key and press it? Okay, I want you to press 5 for statistics. 5. Okay, so you don't have anything in your yes, did you? Oh, yeah, your x scale is 0, you can't write zeros, and your y scale should be 2. Okay, now you should be able to press graph, okay? Okay, so we're bars, and then we're going to press the 5 key, right, for statistics, and then we're going to cursor over 2 to get on EQ for equation. Cursor over 2 to get on EQ for equation. Press Press the enter key. And hopefully it'll take you back to the y equals screen and it dumped an equation in there. Did it? No. Okay, we'd already run our, okay, y equals bars, 5, EQ, enter. Okay, there we go. Anybody else not get the equation to go in there? Okay, once you have these, once it dumps the equation into y equals, you should work, are you still trying to set your window here? Okay. So just do 5.
I think all of it deleted.
No, it's not supposed to look like
I
that.
think all mine deleted.
Okay, so the information that you had on here still had to be on here for it to be able to put it in. So we're gonna have to go and calculate your linear regression again. Okay, now we're gonna go to bars, and we're gonna go to,
Oops.
and we're gonna go to EQ, enter,
Oh, it's supposed to bring you back to the y equals, isn't it?
yep, it's supposed to
But
bring
it
you back
didn't
to
give
the
me
y
an equation.
equals. Or go to the y equals, yes. Okay, oops, that is not what I wanted to do. Okay. Okay, you know what, if you can't get it, here's what you can do. Just go to your y equals screen and type in that equation we wrote there. Negative 1.51x plus 12.90. Just do that, that'll be faster.
Just do that.
Okay, so just type in negative 1.51x plus 12.90. If you didn't get it to work the other way, it's okay. And now press graph. It should draw a line of best fit going through the graph for you. Where are your points at?
Plus 12.9.
This is a turn on. You need your points in there. Okay. Your 4 points should either be touching that line or pretty close because we said it had a strong negative correlation.
Yeah.
True or false? True. Okay. So in other words, what do you think it would look like if it had a weak correlation?
It'll be way off.
The points would kind of be a ways away from the line that was drawn through it, right? Showing that they're not, you know, because the closer they are to the line, that's showing the stronger that correlation is. Okay, so now we're going to talk about the next thing on here. It says, do you believe there is a causation relationship or just a correlation relationship, and why? So I want us to go, turn in your books to page 288, right in the middle. There's no highlighting or anything here, but it talks about causation. Students have a hard time keeping the distinction between correlation and causation. Just because there's correlation does not mean there's causation. Okay? So we have to make sure that we've already decided there's correlation, right? Strong negative correlation. So now we have to decide would there also be causation. So who's willing to read for us what causation is about? What's causation? I didn't mean to yourself, I meant out loud. A reader. Middle of the page, 288, causation. Thank you, Andrew.
Causation refers to cause and effect. A change in one variable directly causes a change in the other variable, and there is a cause and effect relationship between the variables. There is often correlation without causation.
Okay, so again, it says just because there's correlation, there doesn't necessarily have to be causation. There's oftentimes correlation, but not causation. So does one affect the other? Does one cause the other to behave? So what do you think in this situation? Do you think there's also causation?
Yeah,
Okay, why?
because the more you run per week, the less your time is.
Yeah, it seems like that the number of times that you run per week should affect your time running the mile, shouldn't it? Yeah, so it seems like there's also a causation effect, so we're gonna say there is a we believe there is, so we're gonna say there is a causation relationship. End of sentence. It's likely, or in other words, this is, we think there's a causation relationship because it's likely the more, doesn't mean this actually happens for every person, but it's likely that the more times a person runs, the better their time gets, right? You can't sit on the couch and eat potato chips and think that your time running the mile is going to get better. You need to get out and run, right? Seems likely that there should be a causation effect going on here. Okay, questions on the difference between correlation and causation at this point? Again, you have some examples in your book to study also to help you make sure that you understand the difference between the two. Okay, now we're back to something we already know how to do. Interpret the meaning of the slope and the y-intercept. Okay, so what's our slope? Let's write that down first. M equals, what is it?
1.5.
Negative 1.51. Okay, what's that telling us? You know what, let's just kind of, for now, just to make that a little bit easier, let's just get rid of that 1 there. It's about negative 1 5/10. Okay, what's that telling us? Remember how I said the best way to interpret is to do what? Do what?
Like you label what it is.
Yeah, so could we put this over
1.
1, and then this negative sign can go to either of them, but what's the upstairs representing? Remember in slope, what's upstairs?
Or,
The y is upstairs. What's upstairs then? The time. Okay, so the time to run it. So this is, and what's the time measured in? Minutes, okay. So we're going to give that the label minutes. And downstairs are the x's, so what's going on downstairs?
The numbers.
Okay, so times running, okay, so I think that's enough for us to be able to say now, okay, what's this really telling us?
That for every one time you run,
Yeah, let's be specific like that. For every one time you do a practice run, for every one practice run, what happens?
your time goes down by a minute and a half.
Your time for the mile, right? Isn't that what we're running? Yeah. Decreases how much? 1.5 minutes. Yeah. So maybe this will help some of you with that assignment number 67. You have that began interpreting slope and y-intercept. We need to, what does this particular slope actually tell us? Not what are the x's and the y's. The x's and the y's are important for the being able to do the interpreting. What are their labels? Yes. Okay, y-intercept. What's our y-intercept?
12.90.
Okay, so B is approximately 12 9/10 then, huh? Okay, so what's that telling us?
It's going through the wire, so 12
The initial time that takes to run a mile is 12 minutes.
Oh, yeah, because this is really ordered pair 0, 12.9, right? And this is 0, what?
X. 0 times run.
What's our x value again? Times running? Yeah, times, and the 12 9/10 is minutes, right? Okay, so what did you say, Austin?
It starts at the initial time it takes to run the mile or running.
Without any practice runs?
Which-
You gotta run to run the mile, right?
Yeah.
Yeah. So the initial time it takes to run the mile without any practice runs is 12 9/10 minutes. So we're identifying both parts of the y-intercept. We have a 0 for x, we have a 12 9/10 for y. What is that really telling us? Not where it's crossing the y-axis, yeah, that's what the y-intercept is, but what does the y-intercept represent in this particular situation, okay? So questions? Okay, go ahead and put your calculators, the graphing calculators back, because on the worksheet, you're not gonna have to do any graphing. They're gonna have already given you the line of best fit and you'll be just interpreting, okay?